Hello friends, in the last video on depth first search, we have mentioned that the depth first search may not work in infinite state where it may not reach a solution and go into an infinite loop. So we have a variation of depth first search which we call depth limited search, where we supply the depth first search with a predetermined depth limit and cut off the search at that depth. Welcome to our channel Ulhaskumar Gokhale for learning. Today we are going to discuss the topic depth limited search. Let us start with the agenda. So first we'll take a review of searching process. Then we'll discuss the depth limited search introduction. Then we'll discuss the DLS algorithm. Then we'll see how does the limited search works. Then we will illustrate the depth limited search with an example. Then we'll study the DLS properties, and lastly we'll discuss the advantages and disadvantages of the DLS. Let us start with the review of searching process. Okay, the search starts with the root node. So the search will always start with the initial or the root node, and the algorithm picks a node from the open for expanding and generates all the children of the node. So whatever node is there in the fringe, it will be expanded and the successors they are generated. So expanding from a node from open will result in a closed node. So after expansion we have the closed node, so that will be removed from the fringe. So some search algorithms keep track of closed nodes in the data structure called as the closed. Then solution to a search problem is a sequence of operators that is associated with the path from start node to a goal node. So always the solution will have a path from start node to the goal node. And the cost of the solution is nothing but the sum of the arc cost on the solution path. So whatever the path is followed by the operators, accordingly they are summed up and we get the cost of the solution. Then next, the search process constructs a search tree where root is the initial state, and always the search will start from the root node. Then leaf nodes, they are nothing but the nodes which are not yet expanded. They are present in the fringe or expand, and they are also the nodes which have no successors, that is the having the dead ends. Then we go for the next node. Search tree may be infinite because of the loops, even if the state space is small. So even if the state space is small, the search tree will become infinite because of the loops which are present in the tree. So such problem will always return a solution path to a goal node. So this is the general searching process. Now let us go to the depth limited search introduction. As we have already discussed that depth first search may not work in infinite state space where it may not reach a solution and go into an infinite loop. So for that we have variation of depth first search. We call it as the depth limited search or the DLS, where we supply the depth first search with a predetermined depth limit and cut off the search at that depth. So if we are defining the depth limit as 2, then in that case we'll cut off the search at level 2. That is how the depth limited search will be implemented. Then the nodes at the depth cut off, they are treated as if they have no successors, so they will not be expanded and the search will be terminated at the given limit. Let us see the depth limited search algorithm. So here fringe will be the list containing the initial state, and then if the fringe is empty it will return failure or it will remove the first node. Now if the node is a goal node, then path from initial state to node will be returned. Otherwise, it will check for the depth of the node. And if it is the limit, then it will return the cutoff. So that means it will not be expanded. If it is less than limit, then it will add the generated nodes to the front of the fringe. So the nodes are added to the front of the fringe, same as the depth first search. So it uses the stack last in first out data structure. So in this way, the depth limited search algorithm will be there. And how this will work, let us see. So at every node, we keep track of the depth or level of that node, and we modify the depth first search so that if the depth of the node which we try to expand is equal to the limit, then we terminate the search. So if this limit is 2, then we'll have to terminate when we reach the depth 2. Then if we modify depth first search by cutting off the search at a limit, we get depth limited search, which takes as parameter a depth limit and does the depth first search up to that limit. So we are doing depth first search only, but only up to that limit which we have specified. Then let us take an example. So here we have the search tree shown here. So we'll discuss the example. Let us take this example for depth limited search. Now here we have A as the root node, and this will be at level 0. Then we have two nodes B and C. So they are at level 1. Then we have node D and E, again D and G, they are at level 2, and G is the goal node. So we have to find the path to this node. Now here we'll take the limit as 2. So the search will not go beyond this line, red line, which is shown here. So let us start. We start with node A, as node A is the root node. So it will be in the fringe at the start. In the next step, A will be removed from fringe, and the successor B and C, they will be put in the beginning of the fringe. So we'll have the path from A to B. Then from B, it will go to D. Now D and E will be put in the beginning of the fringe. So at D, we check for the depth. Now depth is equal to limit because D is at level 2. So we'll not expand D. So it will go to E node, and then it will backtrack and go to C node, because again here E is at level 2, or here the limit is reached. So it will backtrack and go to node C. Then C will be expanded and it will go to D. Again at D, we'll check whether the limit is reached or not. So here again limit is equal to 2. So it will not be expanded and it will go to G node. And since G is the goal node, the path from ACG will be returned and the search will be terminated. So in this way, the depth limit search will be completed. Next is depth limit search properties. Depth limit solves the infinite path problem, but it will introduce additional source of incompleteness. That means depth limit search is not complete. If we choose the cutoff C less than depth D, that is the shallowest node is beyond the depth limit, then we will not be able to reach the solution. So this will be possible when D is unknown and we choose C with less than D. In that case, this will happen. Then depth limited search will also be non-optimal if we choose C greater than D. If the value of C is very high, greater than D, then we will not get the optimal path. Then next is time complexity. So for depth limited search, the time complexity will be the order of B raised to C, and the space complexity will be of the order B multiplied by C. And then depth first search can be viewed as a special case of depth limited search with C is equal to infinity. So in the depth limited search, we have just kept the limit, and if that limit is infinity, it is same as the depth first search. Sometimes depth limits can be based on the knowledge of the problem, and then we can get the solution in a less time. That is the advantage when we are using the limit. Let us discuss the DLS advantages and disadvantages. First, the advantages. The depth limited search is memory efficient. So it requires less memory because we have put the limit on the depth. Then disadvantage. If we choose a limit or cutoff beforehand, a solution may not be found at that depth. So if the depth is unknown and we are choosing value of limit or cutoff less than the depth D, then in that case we may not get the solution. So that's why that is the disadvantage of the DLS search algorithm. Then to overcome this disadvantage, we'll study the depth first iterative deepening search in the next video. If you have any questions, you can contact me on Facebook, Twitter, Gmail or Instagram. If you like the video, press the like button, share with your friends and subscribe to our channel Ulhaskumar Gokhale. And don't forget to press the bell icon so that you get notifications for our future videos on this subject. Then thanks for watching. Have a nice day.